Greetings, chemistry students. Let's go over your objective check on predicting products of single and double replacement reactions. So let's start with Form A. We're going to be on Form A. It's going to be out of 10 points. The directions are write the equation, predict the products, balance, and then also include the states of matter and balance. Oh, balance twice, sorry. And if there's no reaction, write NR. So let's start with number 1, sodium bromide plus sodium iodide. So first thing, we've got to figure out what the ions are. Sodium is always a 1 plus. It's in column 1. Bromine is in column 17, 7A. It's always a 1 minus. And solid iodine. This one you have to be careful of. That is diatomic. So it's going to be I2. Now let's try and actually write the formula. So we're going to have some number of NaBr. I get that formula by looking at there's a 1 plus and a 1 minus. There's going to be some state of matter. We'll come back to that in a second. Plus some number of I2, and they told us it's going to be solid, will give us new compounds. So let's try and figure out what those new compounds would be. It's a single replacement reaction. I have one metal and then two nonmetals. That means the nonmetals will try and switch place. So sodium is going to be the discerning the discerning atom here. It's with bromine, and iodine is trying to cut in. So to see if that will work, you have to go to your activity series. So sodium was already with bromine right here. So if sodium's with bromine and iodine strolls up, will it drop bromine and go down to iodine? No way. It only ever will trade up. So this reaction will not happen. So no reaction. For fun, let's say if it did, sodium would go with iodine. Remember that iodine is also a halogen or a halide, it's also 1 minus. You would get sodium iodide plus liquid bromine, which is also diatomic. And last thing, let's go ahead and put our states of matter in here. Sodium bromide, for this purpose, is going to be solid. Iodine is solid. Bromine is a liquid at room temperature, and sodium iodide would also be a solid. This one, if we had to go through and balance it, see we've got 2 by those diatomics, so I'm going to need to put a 2 there. That'll give me 2 iodine. That fixes that. Now I've got 2 sodium, 2 bromine, and that works just like that. Then let's look at a double replacement example. We have sodium chloride, so let's write out our ions. We have sodium 1 plus. We have chloride, also a halogen or halide, 1 minus. And we have silver nitrate. Silver nitrate, silver is always a 1 plus. Nitrate is a polyatomic, which you have memorized, NO3, 1 minus. So let's go through and actually write those compounds down. So sodium chloride, NaCl. This is a double replacement. These are always going to be in aqueous solutions. So that's going to be aqueous sodium chloride that's been dissolved in water, plus aqueous silver nitrate. And it's going to produce some new products. So how do you figure out what's going on? We have a metal and a nonmetal, a cation and an anion. We have another ionic compound, cation, anion. They will swap partners. We're going to have remember, we always want to have the charges canceling, so the positive has to go with the negative. So sodium was with chlorine. Sodium's now going to go with nitrate. So I'm going to produce some number of sodium nitrate. Now, I'm going to tell you this is aqueous. You can look that up. The clue is sodium group 1 metal, always going to be soluble. Nitrate, almost always soluble. But let's go and check your solubility table. So your solubility table, let's go through here. Sodium is right here. Nitrate, where's nitrate at? Nitrate is right here. Yep, sodium nitrate, aqueous. So for this reaction to take place, to actually occur, the next thing I produce has to be a solid or else a new gas or liquid water. So we had sodium and nitrate. That leaves, we have silver and chlorine, got a metal and a nonmetal. So 1 plus, 1 minus. Those cancel each other out with the charges. It's going to be AgCl. Now, for this reaction to occur, this has to be a different state of matter, or else everything just stays in an ionic soup. So let's check silver chloride. So here is silver and chlorine. Let's scroll across. Silver chloride is a solid. Perfect. That means the reaction will occur. It won't just stay an ionic soup, and we have a new formula formed. And oh, look at this. Everything was a 1 plus and a 1 minus. It's already balanced for us. So all your coefficients are 1s. Looking at giving points, this objective check is 10 points. That's going to be 5 points per problem. So let's see. We'll give 1 point for each of the reactants being written with its correct state of matter with the right formula, and then 1 point for the balancing. So if we look at number 2, sodium chloride being aqueous, double replacement, that's 1 point. Silver nitrate, aqueous, 1 point. Sodium nitrate, aqueous, 1 point. Silver chloride, aqueous, 1 point, or solid, sorry, 1 point. That's 1, 2, 3, 4. And then the 5th point is balancing. We're going to do that same thing, point counting up here. So sodium bromide, solid, 1 point. Iodine, solid, 1 point. Then this one is a no reaction, so let's see. Technically, we'll just give 3 points then for having correctly identified that there was no reaction. Give them a smiley face if they went through and actually said what the products would have been. That's good practice always, but nothing will happen. This will not ever take place. If you've got questions on how to grade it, we'll go over that once we're done over the next form. So let's scroll down to Form B. Okay, so here we are on Form B. Let's again start by looking at what the ions are to get the correct equations. We have aluminum bromide first. Aluminum is always a 3+. Bromide, column 17, 7A, is going to be a 1-. And then chlorine gas. Chlorine gas, remember, this is diatomic. So it's going to be Cl2. If it was an ion, it would just be Cl1-, but diatomic. So let's look at our correct formulas. So we're going to have some number of Al 3+, bromine 1-. So to get those charges to cancel, do your crisscross. Aluminum bromide will be a solid, plus some number of chlorine gas, Cl2 is a gas, will produce a new compound. So we have a metal and we have 2 nonmetals. So aluminum's going to be the discerning partner here. Chlorine's trying to cut in and take bromine's place. So you got to check your activity series. So let's see. Aluminum was with bromine, and chlorine just tried to cut in. Aluminum will definitely trade up, and this reaction will happen because chlorine is a more attractive partner. So let's look at that. So aluminum will now be with chlorine. Chlorine's a 1-. Aluminum's a 3+. So this new compound will be AlCl3, also a solid, plus, now bromine's left out in the cold. You would think bromine 1-. Well, what's that going to be? It's also a diatomic, so it will be some number of Br2. The trick here, bromine is always a liquid at room temp. Good, so I've got all of my reactants and products, their states of matter. Now I need to go through and balance. 1 aluminum, 1 aluminum, that's good. 3 bromine, 2 bromine. Uh-oh, that must mean I'm going to have to go to 6. That's my least common multiple. The smallest number that 3 and 2 both go into is 6. So I'm going to put a 2 out front. That gave me 6 bromine. Now I'm going to put a 3 over here. That will give me 6 bromine. Well, that just gave me 2 aluminum. I need 2 aluminum. That fixes the aluminum problem. Now I've given myself 6 chlorine. Well, look at that. Put a 3 in front, and that will give you 6 chlorine. Let's try number 2, sodium chloride plus potassium nitrate. So sodium chloride, sodium is always a 1+. Chlorine, chloride is a 1-. Potassium nitrate is K1+. Nitrate is NO3 1-. You memorize that. And let's take a look at what the formulas will be. So we're going to have sodium chloride, NaCl. This is aqueous. How do I know that? That's not just solid table salt. It's a double replacement reaction. Double replacement is always an aqueous solution reacting with another aqueous solution, trying to make a new precipitate, a gas, or liquid water if it's acid-base. So sodium chloride aqueous solution plus potassium nitrate, KNO3 aqueous. This is going to produce some new compounds. Here's a cation. It was with chlorine. It needs to go with a new anion. It's going to go with nitrate. That way the positive and negative charges can cancel out. So some number of sodium nitrate. Now looking at this one, sodium, column 1 metal, almost always soluble. Nitrate, pretty much always soluble. I know that this is going to be aqueous. To double check, please go to your solubility chart. Sodium nitrate from the previous problem, yep, it is aqueous. Now for this reaction to take place, the next thing I produce will have to be a solid. So what's left over? We have KCl. So we've got to go and check that state of matter. Not looking good though, because potassium, group 1 metal, always soluble. Chlorine, usually soluble. So let's just go and do a quick check. Potassium is right here. Chlorine is right here. It is aqueous. So all I am left with right here is two different aqueous solutions, mix them together, not forming anything new. Basically, I just have this aqueous ion soup. No reaction occurs. No reaction. Okay, so let's look at the points we're giving out here. So 1 point for aluminum bromide with its correct state, 1 point for chlorine gas formula correct state, 1 point for aluminum chloride and it being solid, 1 point for bromine liquid. That is 4 points, and then the 5th point is for balancing. And our next reaction, well, 1 point for sodium chloride in its correct state, 1 point for potassium nitrate in its correct state, and then let's say 3 points for identifying that it was not a reaction. Give them a score out of 10. Please pass them back, and make sure you've gone through and checked your level of understanding. Has it gone up? Has it gone down? Has it stayed the same after this video?